Hello, today we're doing section 6.3, function operations and function composition. We're going to start off with operations. Let f and g be any two functions. A new function h can be defined by performing any of the four basic operations, which would be adding, subtracting, multiplying, and dividing. The trickiest part about today is actually going to be finding the domain of these functions. When we are doing basic operations, we need to look at our original functions, and we need to look at what happens when we add, subtract, multiply, or divide, our end result. When you do that, you have to decide if there's anything x can't be. And as we go, we'll talk about it. So let's go ahead and get started. Okay, let's say that f of x is 4x to the 1/2, and g of x is negative 9x to the 1/2. First one says, let's add the two functions. So if I add these two, they actually are like terms because they both have x to the x to the 1/2. So I can go ahead and combine those. 4 plus a negative 9 is negative 5x to the 1/2. This is perfect. I can leave my answer like this. There's no negative exponents. There's nothing I need to change. Now, when we talk about the domain, we need to say, is there anything x can't be? So if I look at my original functions, another way to write x to the 1/2 would be the square root of x. Is there anything we cannot have when we take the square root of a number? And basically, we know that if it's negative, it's going to be imaginary. So x can't be negative. So our domain for this function is going to be 0 and any positive number. Now it can equal 0 because it's okay to take the square root of 0, you get 0. We just can't have imaginary x values as our domain. So this is it. These are the two answers that I want to see. Okay, now let's go ahead and try the next problem. This time we're going to subtract. So we have this function, and I'm going to subtract them. So we have minus a negative becomes plus positive. So we have 13x to the 1/2. There's nothing I need to simplify here, and our domain is going to be the same thing. We have x to the 1/2, x to the 1/2, and x to the 1/2. So our domain can be 0. It just can't be a negative number, so that's why I get the bracket, and it could be any positive number. Okay, let's try another set of problems. We're going to do multiplication and division. Now we have two new functions, 6x and x to the 3/4. So if I multiply them, this is why we need to know our rules of exponents. I'm multiplying these two, so what do I need to do to these exponents? I need to add them. So this is a 1, okay? So if I add them, I'm going to change it to 4/4. So I'm going to get 6x to the 7/4. Now we're going to talk about the domain. Okay, remember, I'm taking the 4th root of a number. So here I can have any number. Here I have the 4th root of a number, and here I have the 4th root of a number. So again, you have an even root. We can't have negatives. So our domain is going to be 0 and any positive real number. Okay, let's go ahead and take a look at the next problem, which is division. I'm going to take 6x over x to the 3/4. Now that we're dividing, okay, we want to subtract exponents, so I'm going to change this to 4/4. So when I subtract it, I get 6x to the 1/4. Okay, now I have an even root, I have an even root. So I know that I can't have a negative number, but you also have a denominator. So what can't our denominator be when we have a fraction? It can't be 0. So that means this time our domain cannot include 0. So hopefully you're not recognizing a pattern. Basically what you're doing is you're looking. Can we have negative numbers? Are there any even roots? Can we have 0? Are there any denominators? Okay, go ahead, pause the video and try this. You try on your own. We have two new functions and we're multiplying them together. I do want you to try the domain and we'll go over it tomorrow in class. Okay, now we're going to talk about composition functions. The composition of a function g with a function f is h of x, where g of f of x. The domain of h is a set of all x values such that x is the domain of f and f of x is the domain of g. So basically what we're going to be looking at when we do domain is we're going to be looking at our inside function and we're going to be looking at our end result. All right, so let's just go ahead and get started. Now, if you see f of g of x, it's not necessarily the same as g of f of x unless the two initial functions are the same. So you'll kind of see what I'm talking about as we go on. All right, so I want the composition of f of g of x. So that means I'm going to take g of x and I'm going to put it into f of x. So I'm going to replace this x with our other function. So we have 4 times 5x minus 2 raised to the negative 1 power. Okay, when you do this, we know that to make an exponent positive, this whole thing needs to move underneath. So we're going to have 4 on top, and then we're going to have 5x minus 2 on bottom. And there's nothing else I could do. You can't simplify this unless you simplify all of it. We're just going to leave our answer as this. Okay, so now we have to talk about the domain. So let's look at our inside function. Our inside function, 5x minus 2, we can have a negative number, we can have a 0, we can have anything. But when we go and put it in, we have a denominator. What can't this denominator be? Remember, this denominator cannot be 0. So to figure out what x cannot be, we're going to set 5x minus 2 equal to 0. We do not want that denominator to be 0. When you do this, you end up with x to be 2/5. Okay? So our number can be negative, our number can be positive, but it can be 0. It just can't be 2/5. So here's how we need to write the domain. It can be negative numbers all the way to 2/5. It cannot equal 2/5, so we're going to use parentheses, but it can be a number greater than 2/5 all the way to positive infinity. Okay, so take a look. I have parentheses, not brackets, because if it equals 2/5, I will have a denominator of 0. Okay, let's go ahead and try the next problem. This is f of x. So now I'm going to take this and I'm going to put it in itself. So I have 4, and I'm going to write x to the negative 1, but instead of x, I'm replacing it again, 4x to the negative 1, raised to the negative 1 power. Okay, so I'm going to go ahead and distribute this. So we have 4 times 4 to the negative 1 times x to the positive 1. I'm going to move this underneath because I don't want a negative exponent, and when I do that, the 4's are going to cancel. So I'm left with just x. Okay, so when we have just x, we know our answer, we're going to be fine, negative, positive numbers. But remember, we have to look at the inside function and then the final answer. Our inside function, if I were to rewrite this, I would have 4 over x. So can I have 0? No, because if you have 0, it's not real because we have the denominator of 0. So actually, our domain is going to be every number except 0. How do you write that? Like we wrote the one above. Negative infinity to 0, it can't equal it, so use parentheses, and then 0 to positive infinity. Okay, I want you to pause the video, try the U-try on your own. Make sure you make a good attempt at trying the domain. We're going to use the same functions as the ones above, okay, but you're going to find g of f of x. So go ahead and give that a try. All right, moving on to the last thing is when we're basically evaluating composition functions. So basically what I'm saying is we have f of g of 5. So we're going to take 5 and we're going to put it into g. When we do that, we get 2 times 5 squared. This is going to give us 5 squared, which is 25, and 2 times 25, which is 50. Now you're not done. We only did g of 5. Now we need to take this answer and put it into our f. So we're going to do 3 times 50 minus 8. There's no domain on these ones because we're actually evaluating the function. So we get 142. Okay, let's try this again. Now I have g of 5. So again, I'm going to plug 5 in. We already know that we're going to get 50. I'm going to take this and I'm going to put it into g again. So I get 2 times 50 squared. So 50 squared is 2,500. 2,500 times 2 is 5,000. I want you to try the U-try on your own. The U-try is f of 5. So you're going to take 5, plug it into here. Whatever answer you get, plug it into here again. Any questions, comments, or concerns, go ahead right at the bottom of the video, and I'll see you tomorrow in class.